on the screen I've just started with this is one of our clients in India working on this project with us, and it's interesting because it's both concrete and steel together in the same model. I've just left it on the screen so that you're aware of it, but it's not really part of today's session. So for those that have got the software installed, what I'm going to do is click on the new button on the top left corner so that we completely clear the model out. And then we're going to, you were sent a folder of information which I've shared with you through the Google Drive, which you were expected to download. So that folder, if you've unzipped it, will be labeled AAA workshop files for attendees. So do you have that, Professor Nitton? And Professor Thomas Maker, do you have it?
Yes, sir, we're having that.
Okay, fine. And Maker?
Yes, we have it, sir. We have downloaded it.
Okay, good. And you're able to access it. So I'm going to go into this folder, and I'm going down to an area where it says Structures Various, and I'm going to load this structure called Big Frame. These are a collection of jobs that users have shared with me over time that I'm able to utilize on these workshops and presentations. So down the bottom, you'll see it busy loading the data. It's loading this job has been analyzed. It's got analysis results in it. And on the very bottom of the screen, down the bottom here, you'll see a legend, and you'll see analysis, and then yes. If you want to know what those are in terms of sequence, if you click on the analysis button, you'll see the order. So nonlinear static or linear static will be the first one. And of course, the first yes that you've got there means the static analysis has been done, linear static. So I don't look at that much. It's just down there. The intention of loading this structure is to get you acclimatized with the controls. So first of all, I can, the left button, holding the left button down, I can rotate the structure on the screen. Okay, and you let the button go and it stays where it is. If I hold down the right button on the mouse, you can pan it across the screen. And if you use the mouse wheel, you can zoom in, and you can zoom in and hold the left button down as well at the same time. So that's really important to get to understand. In terms of getting the overall menus, on the left-hand side, this left-hand side here, these are mostly settings that you turn on and off, and they can be done at any time during some other sequence. So you might be busy adding loads and something on the right-hand side in the main screen, and then you need to turn something on that's off. You can come across to the left-hand screen and select an icon. So for example, I can choose either through selecting here, I can select this option, and I have then 3 choices, and at the moment we're showing fully rendered mode. I can go to the wireframe mode. So for people that have been using tools like Start Pro, this is how they work. We have the luxury of being able to work in fully rendered mode as well, and I'll come back to that shortly. And you can see that everything is physically real time and realistic, and it makes it much easier to be able to ensure that your models are correctly connected and so on. All right, so there's a couple of things I want to do before we move on to the analysis. Is that this has been previously analyzed, and so I should be able to look at some results. So I'm just moving around on the screen to a point where I can work at it. On the very top here, you'll see that there is the load case selector. We have a number of load cases on this, and what I would like to do is select load case 32. And if you can select load case 32, there are a number of things we can do to look at results. So one of them would, for example, would be the deflected shape on the left-hand side here. You'll see these icons, deflected shape, bending moment, shear force, axial, torsion, and so on. And at any time you can turn those on. So if I turn on a deform shape, it will deform on the screen. And I can hold the D button down and then use the mouse wheel, and you can see I'm moving the deflected shape. I can turn the undeformed shape off simply by turning off the members and turning off the nodes. And if I click to the right of the nodes, you'll see that only show nodes which are connected to visible entities. So that's quite useful. So the other ones will disappear and hit the OK. Now I've just got the deformed shape on the screen, and I can zoom right into it, and holding the D button down, I can exaggerate it further. But I can also slide along the members, and you'll see that it's giving you the load case number, and it's giving you the deflections in XY, global XY and local X and Y, and so on. So that's a deflected shape. Now I can actually look at results. This little icon down here is quite a good feature. It's called the member contours option. And in the member contours option, I can go and look at things like analysis results. And so one of the things I'd like to look at would be the, for example, the axial force. And you'll now see that we are looking at the axial force on the deflected shape. And I should be able to exaggerate the deflected shape still. But you'll see on the right-hand side, we've got a legend showing the axial force on the members. So the ones where there is the most compression, you'll see that they're in compression, and they're also in tension, depending on which ones we're looking at. I can turn off the deflected shape, and it will revert back to the underformed shape. And of course I can, because I've now got the axial force, that will be what I get when I move along the members. So the purpose of this exercise is to get you aware of the ease of use because of the graphics and because of the real-time, real lifelike graphics in 3D. Okay, so what I'll do is I'll turn off that contour, and I should have an empty screen because I've turned off the members. And there we are, back to where we started. Now, this job has been analyzed for dynamics as well. So I should be able to, if I make a change to the structure, I will lose my analysis results. But if I want to look at the dynamic mode shapes, you'll see there's a little icon on the left-hand side. If you hover over it, it's an infinity sign, show the animated dynamics. So it's actually the dynamic frequency diagram. If I click on that, the structure will start increasing in size. So I can either use the, hang on, I've got to change the load case as well. The load case that the dynamic analysis has been done for is load case 99. So if you go and select load case 99, you'll now see that the structure, the underformed shape is still there. So I can turn that off if I want to, but I'll leave it on just for a second. But I can increase the scale using these buttons here. So I can scale it up so that it moves more. And I can obviously toggle through the mode shapes. So I can also increase the, by holding the D button down on the mouse wheel, I can increase the, a couple of you have got your microphones unmuted. It's probably a good idea. I'm getting some feedback to please turn off your mics unless you need to speak to me. So I'm now showing the mode shape, the natural frequency. And of course, here are the summary details. So the period for this is 0.4 of a second. And I can also turn off the underformed shape now at this point as well. So I'll come back up to the left button here and turn off the, should be able to do that. If I hit the escape button, I'll stop what it's doing here, and I'll turn off here, and then click on the mode shapes. And now I'm looking at the just the natural frequency without the fixed structure, original structure in the way. And if I just use the buttons on the keyboard, I've analyzed this for probably, I think, 5 or 6 mode shapes. That's mode shape 1. If I hit the number 2 button on the keyboard, or use the mode increment buttons down the bottom on this little legend. So mode shape 2. And it's really useful because it gives you an idea, particularly when you're trying to explain to your students or to a young engineer mass participation. And we're not actually showing the mass participation, but if I look at the summary of the reports, you'll find that in mode shape 1, the structure is mostly moving in the Z direction, and for mode shape 2, it is mostly moving in the X direction. And I could look at mode shape 3 will be a twisting type where the mass participation is fairly small. So, I mean, this is a fairly large structure, but working with smaller structures and using SpaceGass for your students and lecturing is quite useful. All right, I'm going to hit the escape button to stop that. Go back to turning on the original structure. I can also look, other than using the member contour option, I can also look at traditional bending moment diagrams. So for example, if I turn on the bending moment diagram for load case 32, so I'll come and select load case 32 again, and it'll populate, and you can see the diagram is shooting out. So M for moment. If you hold the M button down on the keyboard and use the mouse wheel, you can exaggerate, and I can select an area. So I'm going to select an area to look at. So using the left button and moving to the right, I can select the members, and I can then right click, and I can then show the selected items only, and hit the escape button. So I'm looking at an area holding the M button where I'm showing the moment diagrams on part of the structure. And I may have lost you on that. That's okay. I'll catch up. So I'll just escape. What it's done is we have a selection button up here. This is the filter. If you've used Start Pro, they have groups. We have filters, and the filters are a lot more elaborate where you have much more options. So I'll go back to no filter, and that should now display the whole structure again. And of course the bending moment diagram is on as well. So I'll turn that off for now. Getting back to the member contours, if I go back to the analysis results, I can also show bending moments, the Y and the Z bending moments and shear forces using the contour, member contour option, which is quite useful. So if I go for Y bending, it will now change the colors, which will give me a legend accordingly. So working on fairly large structures in 3D is very important that you have a laptop, a computer that is fairly new, and using the better the graphics card. So things like NVIDIA graphics cards are by far better than some of the others, but it doesn't mean that the cheaper cards won't work. They will work. But there is also memory on the graphics card as well. So these deflected shapes are being processed on by the CPU, the parallel processing on the graphics chip, and not through the main CPU memory and the main processor of the computer. It's been done on the graphics itself. Okay, so I'm just going to clear the screen of the. Currently, we are busy looking at the axial forces, so I'm turning that off. So we're back to the structure. So we've looked at mode shapes. We've looked at 2D versus 3D. So getting back to that, I can always go back to, we have 3 different modes of graphics. There's an outline mode where it outlines the members. There is the fully rendered mode. And of course, there is also the wireframe mode. And we'll come back to that shortly. What I also want to do is give you an idea of the importance of when we're going to do a small little project, which will be a steel structure, the importance of the way that you actually do and conduct the analysis, particularly of steel structures. And we'll have a quick glimpse of that now in the very first thing I do. So what I'm going to do is start from scratch, and I can just do an analysis, linear static analysis, and it's my load case selections. I've done all of the combination load cases, and by the way, that is one of the most important things. You only work with combination load cases. Here in India, I've found many engineers working with primary load cases, and primary load cases do not exist in reality. Things like live load, your live load by itself doesn't work. Live load goes with dead load at least. And so the importance of the loads that you choose to design to. So when I do my analysis, these will be a series of combination load cases. Unfortunately, this job, the engineer that did this had just numbers for his load cases. So I know that all the combination load cases are from 30 through to 69, and then the mass load case for the dynamics that I did. So these have been selected. I'm not selecting anything else on here. You'll see on the right-hand side we have the option of linear and non-linear, and we'll be getting into that a bit more as we progress. So if I hit the OK button, there are a couple of things that come out from this. One is that it's lightning fast. A job of the size I've got here on some of the other tools may take close to an hour or half an hour. It just depends, but that took 3 seconds. And equilibrium shows that it's analyzed correctly. So here, I've been in India for 17 years. My wife is India, so I can talk about India. I'm not a foreigner anymore. But as far as our profession is concerned, across the country, there's a lack of understanding in terms of the requirements for steel structures. It is really important that non-linear analysis is used because we have a limit state design code. And so that is the expectation. But because of the tools being used, corners get cut, people are doing linear static analysis, and it's accepted by the people that do the vetting and the approvals and the authorities that they're designing for as well. But things are starting to change. So because of things like SpaceGass, where people now realize, and a couple of the PSUs are using our software and mandating it to be used on certain projects, which hopefully, the other tools that are around there that are non-linear as well will get a chance in the market here. So everything looked okay because when I ran the analysis, the linear static analysis, everything, it took 3 seconds and everything was fine. But if I run a non-linear static analysis, as I need to do for designing to IS 800, you'll see now that my selection is non-linear. I haven't changed anything else, and I'll hit the OK. And I expect that everything should be fine, and we'll soon find out. So this will take a little bit longer because it's doing more. It's taking care of the P delta. If you're not aware of P delta, this is when a member gets displaced. It shifts from its normal position, and there is the overall deflection versus the load, and then there is the internal deflection within the member itself, which is the little P delta. And that is important to be considered in designing the structures. So I think this takes about 49 seconds to complete. So we're pretty close, 43. I'll do this once. I won't do it often during these sessions because it's time consuming. So this one is taking a little bit longer. Let's just see how much more. There we go. Now I get a message that I didn't get when I did the linear static analysis. It's giving me some inputs about there's potential buckling, and I don't know if that's single member buckling or whether it's the whole of frame buckling. The whole of frame buckling is important, and independent members buckling is important as well. So I hit the OK button. It's run, and it's told me that there's something wrong. So if I come back to the analysis again and rerun it, there are a couple of options. One is I'm going to turn the show messages from single member buckling on. And if I hit the OK, I get these kind of messages. Just hang on. Yes, hear me? They must have used, they're not logging in with a password file. They're using the login. It's not the correct, there's the option for using a PWD file, password file. Yeah, Jyoti, are all of you having trouble?
Is this with regards to the importing the file inside the software?
Just hang on. Just hang on. I just want to mute. How do I mute my... No, it should just, if you reset using the SpaceGass utility, use the reset registration, and then make sure that you're logging using the connect using the password file.
Actually, the thing is, we had.
Yeah, there should be no username and password come up at all if you've selected the correct.
Yeah, the thing is that we had downloaded the trial version from online. Is that what we were supposed to do? Because in the file we couldn't find a .exe file.
Yeah, okay. There's nothing much we can do at this last minute. It should.
And the trial version is not
No,
allowing any like importing or exporting the file as in at this moment.
yeah, just hang on. I've got people talking to me both through the through the Google meeting session as well. Yeah. Has anyone got the software working? No one. Yeah, that's the file I shared initially.
Sir, actually, we are unable to log in
Actually,
software. There is some issue.
This is terrible. What do we do? We just revert to a presentation on this. That's all I can do right now. The PWD file was sent. Just excuse us, everyone. We're just talking to Himi on my mobile, okay? And I'm unable to unmute, so you can listen to us in the background. The email I sent initially, the very first one, gave you a PWD file. The password file was attached, and that file was generated by me. And that file, you should be able, that's all you need when you're trying to configure it. You have to the cloud. So one of the options is to the cloud. One is to a hardware lock. The other one is to a Titan server. You select the cloud options. There are the options there. The first one is not the correct one. That is with login and password. The other one, the next one, is with the password file. That's what you use. The password file is in the original email I sent you. It was an attachment.
Yes, sir. We
David,
follow
it
the
would be
same
great
procedure,
if you
but
could show us. David, it would be great if you could show it because I had searched for a .exe file and I couldn't find anything as in that file. So there was no information in the email regarding .pwd file because we are used to using .exe. So for installation,
No.
uh,
.exe is the email gave you a link to download the software and run it, and then it would come up with the options for registration,
actually,
and that's what the password file
Actually,
is.
what we received, if I'm not wrong, I don't know, is a folder wherein this files were there. This files that you are showing, that files is in that folder. Software link we
That's
didn't
separate.
receive. I don't. If I can share, I don't know. Others,
No. The
if
email that
anyone
I
can
sent
come
out,
confirm it.
yeah, the email I sent out initially had the links to get the download of our website, and it had the registration file, PWD file. There was a separate email later that had the folder, the Google Drive. Yeah, correct. Yeah. Is any? Can you just ask if any? I'm on the mobile here, and I haven't muted my mic on Google Drive either. Sorry, on Google Meeting. Can you find out if anyone has got the software running at all?
The software is running, we have installed it, but the only problem is because it is a trial version, we cannot import the files that you have given in the folder. That is the only issue.
It's
Otherwise,
running.
we
Is it?
can see everything what you're doing and we can, yeah.
It shouldn't be. It shouldn't
So
be a trial version. It's
the first,
the license registration you've got is for a commercial license. It's not for a trial license. You're not running a trial version of the software. You
probably
should
this
do.
must have,
You can't import?
No, we cannot import because import and export is not allowed in the trial version. So I think we are like our college. We have not received a mail regarding this. So if someone can forward it, would be great. If
Yeah,
someone can put it in the link or in the chat box, that would be great. And we can move ahead. We will look into it. I don't want to take much time of you with regards to this. We will do it.
yeah, this
I
is
think
what
that would be
happens. You've
if
had all
someone
had. I'm not lecturing any of you, but you've all had weeks and weeks to get this organized, and now at the last minute we get to hear this. So I'm sorry it's happened, and we can only learn from that. But okay, and so what you let me know at the end of today what the status is as well, Himi. I can regenerate the password file, which means reset it, but I have no idea the lady that was just speaking to me where the trial version came from, unless they've downloaded the trial version separately, which is not what we need. Like that can run, that should be uninstalled, and they should install as per the instructions I sent to you. And that first email. Cool, that should be all. Thanks, Amy. Okay, thank you. Okay, bye. All right, am I back online? Can you hear me, Nitin?
Yes, David, we can hear you.
Oh, that's good. Okay, I can't hear any of you, and I'm sorry about this situation occurring, but life is too short. We'll resolve it. I can regenerate the password file as well, but if I do that, it means the people that are running their files will become invalid, and they'll have to re-register using the updated password.
Yeah, no. Let's not do that. No, we won't do that. We'll just keep trying at our ends if ours starts working. That's
Okay,
fine.
fine.
Please go ahead. Please.
All right.
Thank you.
So getting back to what we were doing is I'd run a linear static analysis and everything was fine. It took 3 seconds. So from a linear static perspective, I have results, which means I then can actually start looking at bending moments and shear forces, and I can also start doing design using the design codes. But as soon as I ran a nonlinear analysis, I found out that there were issues, and it mentioned the fact that there was possibly buckling happening in the structure, and that a buckling analysis, which is a separate analysis that we do, should be run as well. And now I'm running up this. There was an option I ticked on, which was to show single member buckling, and it's told me that member 40 is buckling for load case number 34. It'll allow me to continue, so it means it just keeps on the process. And I'll most likely, then I can suppress any single member buckling, and I'll say no. And it'll then go through further and pick up probably 2 or 3 or 4, or member 40 in this case, continue with the analysis. And remembering that we ended up with an error, overall error at the end, which related to buckling as well. It's now told me this one has failed as well. Once again, it's a different load case. Continue with the analysis. Of course, I can say no and terminate at any time, so I can click the no and just exit out. But just for the sake of showing you that at the end, we end up with the same result at the end of the analysis. And it will now step to the very end. And this analysis takes a total of 1 minute 22 seconds when I don't interrupt it. So while this is going too, is that we are in the process of releasing the educational version on Cloud Server, and that will solve a lot of your problems. It's for free, and I'll keep you all updated on the status of that. But what we've been using with you right now is we've actually installed a commercial license server, and you're having problems. Okay, this is now back to the original message. So I can see that there is some issues. And of course, now I'd want to explore member 40, and I'd go into more detail. And then, the frame would get to a point where I wouldn't have these messages, and then I would go into the buckling analysis as well. And we'll get a feel for that when we get into the workshop session later on today. Okay, while I'm here now, the structure hasn't been analyzed, so I'm going to go back to, I can play around with it, turn back on into rendered mode. Use these filters here. For example, I want to look at part of the structure. There's predefined ones like the platform. And it is not a passive view, this is real time. So if I had a deflected shape, I could turn it on and it would show the deflected shape as well. What I want to do here is the concept of the wireframe, looking at this in terms of the wireframe and looking at it in rendered mode. And in the having the alignment of these members or arranged properly. So we want the tops of members. It's becoming really important now in engineering where they're using building information management tools. And so physical and analytical concepts are very important. Physical is that it's physically built the way that it's shown on the screen, and it's correct in terms of where it's positioned. And analytically is that it is connected correctly. So from an analysis perspective, we've got two things we need to take care of. The SpaceGass is pretty good with this because if I'm working in, by the way, the escape button on the keyboard is often used when you want to escape out of something. So if I highlight this and select that, you'll see down the bottom of the screen, bottom left-hand corner of the screen, it's got an option pick member or corner of window. So when you've done something on the screen, it's always prompting you down the left in red text. I'm going to select these members and this one as well. And then, so having now selected members, the tool is pretty cool, easy to use, because if I now just click the right button, these are the things I can do to those members. And there's a number of member tools. And when we get your software up and running, you can have a look through each one of these as well. I presume there'll be a recording, so you should be able to backtrack, to what we've covered so far today and follow that yourself. So looking in the member tools, there's an option here to align members. And now I have a prompt down the bottom left. It's asking me to pick the source member. So it wants to know the source member that I want to align with. And of course, the source member is any one of these along here. And then it gives me a choice of top alignment, which is what I want. And you'll see that it's moved the members to the tops. And if I go back to the wireframe diagram, what you'll see is this. And of course, there's a reason why a lot of people don't like using offsets. So to get the physical model correctly, there are a lot of offsets in the structure. And if I turn the offsets on, so show member offsets, you'll see their offsets are now being displayed. And if I toggle back to 3D, I've satisfied both criteria. I've got my members positioned exactly where I want them. So if I now do any exporting, if I want to export this to a 3D system, the orientation and the positioning of my members will be correct. But this leads to the problems with tools like Start Pro, is they're having to work a lot of the time in wireframe mode, and that is particularly why a lot of the models that I get to see are not positioned correctly, because it just becomes too difficult to work with. All right. The other thing to quickly have a look at is we have data sheets. So the structure that has been loaded in here, you'll see that there are ticks wherever there is a tick. So if we have the physical geometry, nodes, members. If I look at nodes, it's like a spreadsheet. It can work. If you click on the right, you'll see you've got options for exporting and importing and duplicating and so on. And so the data sheets become very useful. I've also got a number of data sheets for the loads. And if I come to member concentrated loads, if I want to sort any of these rows, I can sort just like I can with a spreadsheet. And of course, I can highlight a certain number of rows using the shift button. And then I can right click on any of the fields and replace it, add to it, cancel. So you have the ability to come in here, make changes, and then of course it will have the effects on the graphics as well. So the change will be made physically. The other thing to look at, one of the real strengths of, I'll go back to rendered mode and go back to no filter. There is a central frame, for example. You can create your own groups on the fly as you want to. And the thing about groups is that they can be based on a number of criteria, and not just on a selection of a group of members. They can be selected by material. They can be elected by the actual plate thickness on plate elements, and each one of these are down the left-hand side. Getting back to, one of the major features is the import and export. So if I come down here, and as someone was talking to me earlier, you say you can't import and export, which means that some of these would be grayed out. So the commercial version that you've got, everything should be available. And we have a number of export options. One of those is Excel. Excel is really good, but you'll also see we've got STD. So let's show you how these work. Just once again now, clear this job, and back to an empty screen, and file import. And from import, I'm going to import from Start Pro. So one of the things we did was to do a lot of work on the Start Pro interface. So you need to go to your folder. Back to the AAA folder. In that, you'll see there are some import options and there are some export options. So I'm going to import options. In the options for importing, we've got STD and a number of other options there as well. These are where the actual files are. And then you'll find a whole selection of STD files that have been shared by various people to me over time. So I'll just select the first one. We get a dialog box. It's going to create a log file. Once it reads and processes the file, it will actually create a log file. And we'll have a quick look at the log file at the end of this. I'm also able to position what I'm importing physically elsewhere. And there is a couple of options here to help to try and get things connected in files that people have not connected structures properly. So hit the OK. And it's busy replace. It's going to replace the log file because I've run this before. The dialog up here telling you what it's doing. And this is basically a work in progress because we get feedback of certain features of the STD file that we may not have considered. And we take that into account and make some adjustments to the import or export tool. It will now load, and it'll ask me if I want to look at the log file. And the log file is pretty easy to understand. It's referring to the line number in the start file, and it's giving us references to why it is not reading that particular set of data. And this is really the member file proofing is not a command that we have in SpaceGass, so the user has to work out what they want to do to account for that. The other ones, these two lines here are to do with section properties, which are not being able to be interpreted, and so it's giving me the details there. The rest, all of these are here to do with the fact that what we do when there's a comment behind a load is we actually create a load category, and you'll see when I go to the structure now what that actually means. So if I turn on, here's the load case selector. If I turn that on, but what I want to turn on are all of the primary load cases. And just hang on. I want to turn all the load cases on. If I click on this button, you'll see that on the right-hand side here, I've got the primary loads, so load cases, and then I'll have for each one of them. So if I select the live load, for example, the live load's got a number of categories that have come down. And if I hover over one of those, you'll see that there's some comments there. Notes, staircase loading south side. That's been picked up off the loading the actual load command, each one of those load commands as you move down through the file, and a category's been made. So we can look at the category just by itself by clicking on it, and we can see where the loading is. There'll be two types of loading. Usually I can scale the loading as well. So let me turn on go back to load case. Yeah. So I've got all the load cases on at the moment. If I hold the L button down and use the mouse wheel, you'll see that we've got the traditional loading method, and there'll be loading at nodal loads, which are concentrated loads, and you can see I'm actually exaggerating them. I can turn the text on, and so and of course show annotations of nodes and stuff as well. All right, so just the results of the loading and being able to move around between the primary load cases. So the first three load cases here are the seismic load cases, which will just have mass values in them. And then the live load itself has got a number of subcategory loads as well. So at this point now, I can analyze the structure. I can check it and so on. All right, so that's the Excel import. Not Excel, STD import. And we're going to come back and use the Excel import with the little project that we need to run. If I come here to import again, I'm going to import from STL. And once again, I need to go, it's the first time I'm going there, to the folder. Okay, I'm in the folder that you will have access to as well. And in that, you should have the import options and STL. Right, so what is STL? Many people don't know that STL stands for stereolithography. It is a 3D printing file. And a lot of the 3D tools that we're using now include the ability to read STL. And SketchUp is one example. SketchUp is a BIM tool which is really good for engineers. Some of the BIM tools are really complex. They're more for drafting. But SketchUp is really, really good and a good investment to have as well. If you have anything which has got surfaces on it and there are unusual shapes and unusual designs that you want to have, you can draw it up in SketchUp and export it using STL. So this rib tank, and I've got a number of others there as well. One of them is a real job I was involved in, which is the building in Dubai, which has got really incredible facades of glass work. All of the glass work was modeled using SpaceGass, but the actual the geometrical modeling was done using SketchUp and using an STL file to export it. So basically the concept you'll get here, we have automatic meshing in SpaceGass. We have a number of tools that do automatic meshing. And when we first started, it goes back 4 or 5 years back, when we first started completing the automatic meshing utilities, we had to work out how to use it. One of the biggest challenges as a software company is the user interface and designing a user interface which is usable. So we were looking at ways of making use of the automation of the meshing at a very, very early stage. And one of those was the STL option. My units are all in meters. And what I have a number of options. These are part of the automatic meshing controls. I want to make the element size no less than 10 millimeters and no larger than 0.1 of a meter. There are a number of options here. One of those is to allow invalid elements. Invalid plate elements are ignored here as well by a number of people that are using other tools because, first of all, sometimes they don't get told that there are invalid elements, and they don't understand the importance of having invalid elements in areas of high stress levels. So I would want to go and check where these invalid elements were if I had them, and then decide whether I could ignore them or not. We're going to make the plate 30 millimeters thick. It is made of steel, and of course the library here is set by default to steel. We have many libraries, and we'll see that as we progress through the session. And I have the ability to add perimeter members. It's like having a slab with a beam running around the edge of it. So it could add, and then I'll be able to define a section property for that. Here I've got everything I need to do at this stage, and I'll just click OK. And there we are on the screen. One of these ribbed bins that are used for water supply. And I've just brought something very simple out. This has been meshed, so let's turn the meshing plate edges on so we can see it. And one of the things we probably want to show quickly is I'm moving around the structure and I'm trying to highlight a plate element. And there are a lot of nodes. We have an option to have hidden nodes not being appeared, but I've got mine turned on. If I don't want them, I can always come and just turn off the nodes to start with. If I select that member, there is an option up here, or if I right click, you'll see I have the same option, check connectivity. It's that. So I'll just escape, select the member, check connectivity. We have a number of options, including finding substructures, which are really useful. And very quickly, this whole structure should just find substructure. I should have only one, and then it'll highlight everything that's there. And if we have multiple substructures, you'll be able to see where they are. So if I select, let's select this again, click on this one. I'll go to the first option, which is just check the connectivity. And so I can move around the structure and I can check connectivity, see how things are connected. And I can even go inside the bin. And if I want to work on the edges, instead of working in 3D, I can go to a wireframe. And so I get to see the edges much easier. I can select them and get the connectivity. So they're the wall and the floor connection, right? The importance of graphics and the importance of being able to model something like this. So we could do a couple of fancy things with this now very quickly. I'd like to be able to analyze it and look at deflections and so on. Well, the first thing I want to do is on the base of the tank, all of these plate elements are there. If I turn on the local axes, these are the member local axes, you'll see that they're all pointing outwards and downwards on the bottom floor. And this is really useful because it leads to the fact that we can show plated structures, and we can show stress diagrams, we can show areas of steel. If it's a concrete slab, because the direction of Z is the vertical and X and Y follow the global X and Y. And so we don't have to worry. It's a challenge for some systems where when you're trying to look at analysis results or design results and contours, you have an issue with the local axes on the plate elements, and you have to rotate them and have them all aligned so that you can actually get a result. So in SpaceGass, you don't need to worry about that. It's taken care of in the system. Okay, so I'll just turn off the axes on the left. There's an option, Control Shift and Select. We have a lot of hotkeys, and if you right click on the thing, you'll see that some of them are, as we get through to the menu, I'll just click there. You'll see that some of them are given on the right-hand side. Control Shift and Select means that everything is on the same level, the same plane, has now been selected. And there are a couple of things I can do. I can just leave it selected and just apply what I want to do to it. Or I can click the right button and I can show the selected items only. And that's always that. And if I do that and hit the escape button, everything's highlighted. I've got the base all by itself now. If I now want to create a subgrade modulus of elasticity restraint, reaction, what do you want to call about the support for the structure. So it's going to be a subgrade elastic support for the base of the tank. I've got it isolated graphically. If I want to do Control A, if there are members and nodes as well, it will tell me and give me the choice, but they're just plate elements, so it automatically selected them. So once something is selected, the same thing is right click. You'll notice I tend not to use much of the menus, which a lot of the commands are up there, but I use the right button on the mouse, and it's very intuitive and very easy to get to. So something is selected. It's a set of plate elements. There are specific things that I can do with the plates, and then there are some plate tools. And one of the plate tools is to generate plate spring supports. So if I select that, the dialog will give me a subgrade modulus of elasticity, 100 pounds per square inch, 35,000, 40,000 around there. And that will now be applied. And it'll generate these are, if you look at the member and look at the detail, it's a compression only member. It's automatically connected itself to the nodes on the plate. And each one of these, if I hover over the nodes, each one of these has got a spring constant, because you'll see that there are 6 degrees of freedom, F, S, F, 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 which X, Y, Z translation is the first 3, and then the rotationals are the second 3. So each one of these compression only members will be connected to a node which is fixed in time, fixed in space, except the fact that it's got a spring constant in the vertical direction of 290. And that spring constant will be different at each one of the nodes, because it's basically based on the area of the plate elements that it's supporting above. The other thing to note too, let's hit the escape button, is that the compression only member has node A and node B. And in this case, node A is at 2441 and node B is 2303. The other option is I can turn the local axes on and I can see where node A and node B is. But basically node B is the one at the top, and it's been released for rotation around X, Y, and Z. Okay, so that's my support for the structure. Now I may want to apply some hydrostatic loading into the tank. And if I go back to the fact that I've got part of the tank, currently it's using a 1000, which is a temporary filter, which was created by me when I selected what was being shown. All right, so now I'd go through the process of applying a load inside this tank. And it's going to be a hydrostatic load. And I want to know something, the nodes are on. So I want to know something about the top of the structure internally. 2.25 meters wide is the top of this building. I want to select everything that is vertical in the structure. And how do I go about doing that? So if I select all the plate elements again, that's what I'm going to do. I can do it in a number of ways. We have currently in perspective mode, I can go into orthographic view, which means if left to right, creating a window is everything included inside that window, or right to left, which is cutting. Those are 2 options I have as well. The other option I have is I can select all of the plate elements which are vertical. That's one option. And how I can do that if I come to my little binocular and each one of these plates needs to be selected. So I just select the whole lot. And because I've got nodes and I've got plates, and if I'd gone further down, I've got members as well, which are and of course now I can go here and I can show selected item only and hit the escape button. So that's what I've got now, is I've only got the plate elements which are in the structure. And now I want to select them all again. Excuse me. Control A. Select all the plates. Come here to this little binocular and look for all plates which are vertical. And now I can show the selected items only. So you'll realize that this is a rib tank. So, and what it's done is it's separated the sections that are horizontal from out of this. So now I can merrily go ahead and do select all the plates, right click. I can go to the loading options And in the loading options, you'll see there is an option to apply varying pressure loads. So I can select the varying pressure load. And it's going to prompt me down the bottom to pick the start of the load. Now I want the origin, which I know is the bottom of the tank. That's one way. I can go and pick it, but I can also use the keyboard to type 0. And you'll see now that it's also moving when I move around. This is where it's going to, and I can go up 2.25. And then it'll bring up the dialog. So from the bottom to the top, I want it to be, it's 2.25 Newton per square meter, pressure at the bottom, and 0 at the top. The load case that we've got here, load case 1, it's picked up details from the pressures I've defined for the category, load category that we have. So I'm going to write here, this is my little place, so I'm going to actually add some wording. Hydrostatic wall varying pressure. Hit the OK. I could change my load case. And title for load case 1. Hydrostatic. And you'll now see if I can look at this in two ways. The load, traditional loading diagram. And if I go back to this cube and I select the plates, another way of looking at the plates like this, show selected plates items only, move it like this, you can see the loading. I can turn the loading annotation on, but I'm not doing that at this stage. Okay, so well, let's go there. So you get a lot of text turned on. So there are better ways of doing it if I turn the text off. Another way of showing this diagram, so if I just get rid of this filter back to the whole tank, is I should be able to show the load in a different way. So we've got the options for plate pressures, contours, and Z local pressure loads, which are the plates. And it's now showing, you can see the legend here, so using contours of the loading and so on. So now I'd go and apply a separate, I'll just apply the pressure loads on the bottom plates and add that into the hydrostatic loading. I'm going to not do that. I'm going to just define the dead load. There's a little icon up here. So to do it very quickly, yes, I know I've got data sheets and that's where it goes, but this will actually open the data sheet. And the load case I want, currently load case 1 is hydrostatic. I want load case 2 and -1 in the Y direction. And then it'll ask me for the name and it'll be dead load. So I've got load cases 1 and 2 being dead load. I'll come into here, I'll go to my combination load cases, and load case 101 is going to be hydrostatic 1 and dead load 1. And then I'm going to do my analysis and linear static analysis at this stage, because I just want load case 101. And you'll see that it's fairly quick. This is really useful tool, SketchUp, for connections. I use it a lot. If you've got, particularly with cold form sections, you've got weird connections or weird section types as well. Some of those Z's and some of the very fancy ones, we've got them in a library, but they're not. And I also want to check the connectivity, the connection design for them at times. So for the knee brace on a portal structure, to be able to model up the connection between two sets of cold form sections can be quite daunting. So SketchUp is very good at doing that. I don't know how long this one takes, but I assume it'll be finished in the next 30 or 40 seconds. By the way, when I ran this, I ran linear static. I can run nonlinear, and we have nonlinear plates, and they're there is a tremendous amount of help in SpaceGass. So once you've got your versions of the software working, you should be able, any of the dialogues that come up on the screen, refer to the helps, and you get a lot of information, a lot of technical detail as well. And there's a lot of information about the nonlinear plates and the theories that we're using. So there's large deflection theories and small deflection theories based on the plate types that we've got. This should have been finished by now. Okay, I mean, it feels long when you're in a session like this. 1 minute 35 is not long at all. In my days when I was a young engineer, we had mainframe computers. We used to submit a job and we'd have to wait 2 or 3 hours before we'd get a result. So now I should be able to show the analysis results. And if I want to look at the, for example, turn off the members and only show the nodes that are connected, I can look at the base as well. And we can come to the contours here and analysis results, and we can look at von Mises stresses, for example, for the load case that we've analyzed, 101. Right, so you've got your von Mises. I can also look at the analysis results, bearing pressure, and it'll be quite similar. So that's the bearing pressure. I can also turn on the deform shape for both plates. I won't turn on for members, and I'll turn off the deform shape for the plates. And you'll see now if I hold the D button down and hit the mouse wheel, I'm increasing the exaggeration. D for deflection, M for moment, S for shear. There's a little scale ruler on the top menu if you can't remember them, and in that it tells you what to use. All right, so I'm using D for deflection, and that is at their displacement factor. And so what's basically happening here is the subgrade modulus of elasticity is basically pushing up the base of the tank. Okay, so the tank is sliding down the side, and those deflections, you can measure them, they're fairly small. On the bottom, you can see it's 0. And but if we go up here, the deflection increases. So I'm not looking at this. We can also look at deflection on the analysis results. If I come here to total displacement, there you've got. So I can see it in terms of coloring in my legend, but I can also interact with the plate elements on the screen. All right, enough of that. Any questions? We're kind of halfway through the session. Are there any questions from anyone? Professor Thomas, are you there? Professor Newton, are you there?
Yes, sir, I'm here. Yes, I'm here,
Okay.
sir.
Good. Any questions from you?
No, sir, all good as of now.
Fine. Okay.
It would be great when we do it hands-on. We'll get more questions. But I felt that the software is very great with regards to nonlinear analysis, and will have a lot of views for our students as well. So
Yeah.
that was a great session. Thank you.
No, fine. It's difficult when you can't see the audience as well. So, but at the same time, once we've got your software up and working, in the next 4 or 5 months, I've explained that there is the educational license, and the educational license has no restrictions. It's exactly the same as commercial, except the data files are different. So it means that you can utilize it, without any compromise. There is no trial. Effectively, the trial version is what the trial version is for. It's for our commercial customers. That there is actually a student version, which the students can take themselves. But yeah, I prefer to have everything centrally managed. It'll be on the cloud, and so you won't need to worry about having to manage the servers and stuff like that as well. Anyway, I'm going to move on. I just want to have a drink of water and request a cup of tea. Maybe a few of you others can do. I'll speak 2 minutes. So if you have a 2-minute break, I'll be back. All right, I'm back. Excuse me. So back to a blank empty screen. There are, as I said, I've shared a lot of data with you. In the structures various folder that we went to get the big frame from, you'll see that there is a number of others. We'll do them first. Go to this cable structures. And I like the shade sail one. Cable elements are used to model these kind of tent type structures. It's also used to model glass. We have most of the glass facades, the fancy glasses on the new sports stadiums, particularly ones in Australia. We've got one of my close friends who has done all the detailed design and analysis for those using SpaceGass. So they use SpaceGass for mainly for glass. So the fact is that there is no compression. Glass does provide some tensile, and it's got limited flexibility as well, depending on the type of glass. So you can get about that. But the issue here is how to, and I'll show you how to analyze this. So if I try and analyze this structure, I think there's only one load case in it anyway, and hit the OK button, I'll get these kind of things. Now, what I like about SpaceGass is it's quite particular, quite specific. It's telling me there is instability found for translation along the x-axis at node 63 in load case 1. You can't get more clear than that. And it's very easy then to go back to the structure and find that node. So we can go and just show you that we can find it. I'll just hit OK. So node 63. And I'll just cancel out of this one. So I can go and find using the binocular tool. And I think the binocular tool, if I right click, find is there as well. And find node number 63. And you'll find it, there it is, node 63. And if we look at this is looking at it in 3D. If we go back to rendered mode, if we go back to wireframe mode, that's what you've got. So you've got this cable net made up of cable elements. Each one of those, if you hover over it, is a cable. All right, so that error I got, if we go back to just getting the dialog, if I go to nonlinear static analysis, which I did last time, you'll see that there is small, large theories. And of course, if you change linear and nonlinear, it will have some impacts. The help is really good. So if you toggle down here, first of all, it'll cover each one of the parameters on that screen, damping. So to get this to run, there is going to be the involvement of damping and load steps and applying load gradually and carefully, because just applying all of the load. So basically what we were doing is applying all of the load instantaneously on the cables. And so getting it to iterate to a result is just not going to happen. So you'll find that wherever there's a dialog box, there's a help screen. And if you get your software up and running, hopefully today, then you can do that as soon as you want to. Anyway, so I could set a little competition here. Please let me know if any one of you can actually get this to solve. If you've tried a number of times and you've not prepared to carry on, ask me to share with you one of the solutions, and I will send you the parameters to enter here, and so you can actually look at the results of the structure. All right, so that's the concept of cables, and related to that still, even though it's not cable, it's a bridge. We've been used on many bridges, so SpaceGass is a general purpose structural engineering tool. It's designed for structural engineers for structural engineering. It is general purpose, but we do very specific stuff, and when we do that, we have to make sure we don't compromise the general utilization of the software. And I'll relate to that when I get there. I'll show you. We'll be going through an example. So not cable structures, but bridges. There's one that we are very popular and very well known at IIT Madras. And Professor Mayor Prasad, I just, since lockdown, probably my visits have drop, but we spent a lot of time with their postgrad students running workshops, very similar to what Hemi's been doing with NIT2TR. But ours has been more postgrad students facing as well. We do that at IIT Delhi from time to time. All right, this bridge is a real bridge, and the actual physical structure, was generated from the wizard in Midas, and we imported it. So getting back to the import tools, we imported that using IFC4. There are some problems with Midas's IFC4 file, so our import files so if we go to file import, I'm not doing IFC today, but IFC step, you'll go and select import options, std, IFC4, and for example, etabs has got one, Midas has got one there. No, I haven't got it. Etabs. I just want to get this to come up with a dialogue. Yep. So here we have a number, trying to read it, but there are some issues with the Midas getting back to convert from, and you'll see that we've got an option for Midas, and so we've corrected the errors. So, and I haven't done this for 2 or 3 years, so we'd probably have to review it because they'd be updating the IFC4 export options, and there may be different issues. So we try and correct the errors in the file. We have the same issue with SAP when SAP generates an IFC4 file. The nice thing about IFC4 is that so you can use it for importing plate elements as well. So IFC3 was just members. IFC4 includes plate elements. Anyway, what I wanted to show you on here is that our moving load feature. And if I make this fully rendered, I want to be able to see the vehicles moving on this on the bridge, just shrinking it to size. We have the ability, getting back to the left-hand menu, the transparency, and so you can change transparency of the members, and you'll see it doing that. All right, and I can leave it on the screen. Up here, you'll see a little vehicle, and it generate moving loads, view the moving loads, so we can view them, and we can set speeds. We can show the travel paths, or we can view the loads moving. Let's view the loads moving. And you'll see that I've got groups of vehicles going down 2 lanes on each side, and of course this is generating both the primary load, primary load cases, and also allowing you to combine them in with other load cases as well. So it will generate both the primary and the combined load cases in one tool. If I make that a bit slower, and then we can have a quicker look, and you can see the wheels are there. And so we have both wheels and tracks, and of course that's moving in different directions. So at each step, you define a step, so at every 1 second or whatever it is, you're picking up a snapshotting and getting a primary load case, which are then combined into other primary loads that you select. So dead load, for example, and live load if you want them included. All right, so I'll escape that. And going back to the other option, if we then go into generate moving loads, you'll see all the input, and all the vehicles are here, each one of those vehicles. And of course, we can edit each one of them as well. So if I look at this one, edit the vehicle, you can see, so we have libraries of vehicles, and getting back to, you have a choice of pressure. So you can have a track, and you can have travel paths, and you have proximity settings and stuff like that as well. So the moving loads feature is really useful and very powerful. All right, so playing with meshing. We've done some automatic meshing. We use the STL import option, and that generated plates. But there are a number of tools to manually and automatically create plate elements. It's actually, I'm going to come to the tank model in a bit, but let's go and look at this. Particularly when we get to water-related structures, we have quite a lot of features. People that are working with water, both hydrostatic water supply and also for sewage, wastewater type stuff. So if I come back here and open up a job, and there are quite a few in this folder called meshing examples. There is an underneath tank. I'll bring up the first stage. You can see there are various stages that this goes through. So you can look at each one. I'm just going to start with the very first one. The good SpaceGass users, like myself, not I'm saying proudly, but we use members very heavily as construction lines. So that's what I've done here is I've very easily drawn. This is a water treatment plant tank, and the dimensions, if I hover over that, you can see it's about 24 meters, and the height on this one here is what, 7 meters. Yep. So it's a decent size. But we have I have clients working on very large ones where they're 100 meters, and so they're very, very big. So it doesn't really matter about size. But now that I've got all the physical connections and stuff, we have one tool. As long as the plates are in the same plane, is the condition for this one. And you can see what I've done is I've selected that side. Members are selected, so if I right click, you'll see that there are member tools and there are mesh tools. And we have generate plate mesh from members, which is what we're doing. So it'll bring up a dialog box, and that dialog box will be first of all the sizing of the plate elements. So default mesh size. It also gives me the ability to control the boundary. So the boundary, I'll just say 0.5. It all comes down to where hard nodes. I can go and put hard nodes inside. We haven't done that, so it's not going to actually make any difference. But if I put a node inside the member, anywhere, it would make use of that size of member as well. And then internal plates, and I'll make those 0.3 as well. On this side here, plate thickness. So this is a concrete tank. So let's say it's 350. And we have, it's one of the other features too. Of course, you can have offsets on plate elements. A lot of tools, you don't have that facility. Start Pro, you can't do that. It becomes really important when you're modeling for something like a floor slab on a multi-story building and you have drop-down panels. So where the drop-down panels are and the actual slab, they have to be offset from each other by the difference in thickness. So the drop panel is thicker. If you have, for example, water tank, and you have walls which are basically from top to the bottom and sloping, and you basically as you go down the wall, you would need to have offsets to be able to define the tank walls as well. And I'll show you that if we get the time. Okay, so what else do I need here? Plate offsets I'm not using. Material, it's by default using one of the concretes in the library. We have a library here. This is the Indian Library of Materials. So 30 MPa is the concrete level. I want to preserve the existing plate edges, and I don't want to subdivide the members because they are construction lines, and I'm going to remove them completely afterwards. So if I left that turn on, the meshing would actually mesh the member as well. You can control the numbering. I'm going to attempt to correct invalid elements, and let's go ahead. It may tell me that there are more than 5,000 elements. It might tell me that they are nonlinear, but no, it's done it. Now the meshing has been generated, and I just want to turn the meshing on. So we have edges for both plates and for members to make them look better. So you can see what it's done. Now I can carry on, because if I want this face done, I didn't break up the member on the left there, so it makes it very easy for me to come here and do this. And Same, yeah. Go to the meshing tools, generate plate mesh from members, and hit the OK. And it'll automatically link in if I come to these plate elements here. Hit my escape button, select that plate, check connectivity. You'll see it is connected each one of these points down through the structure. Okay. In basically, it's what you do is you build up that. You can play with that as well. That's why I've given you that data file. You can just do the whole lot. And there's a step down as well. You can see over there. So you know how you do that. And the member for this one, where is it? I haven't defined it. Okay, it's interesting to know. All right, that's that one meshing tool. If we had a lot more time, I'd spend more time on the meshing because but what I've given you means you can control through it and see. Building with walls. Okay, there's a single story one. So this one can be really useful to start with using one of the other tools that we've got. It's a little bit time consuming. But basically, I've got these beams. So if we can look at these in rendered mode, this is what the structure looks like. There are some walls, and on top of the walls there are some of the walls. There are nodes that we can select, and the elements connect down through onto the plate as well. So I'm not going to do anything with it, but I'll just very quickly explain what needs to be done, but I won't go through the whole process. First of all, I want to go back to wireframe. Okay. Yeah, what I want to do is I want to be able to create the plate surface around the structure using these beams that we've got. But I can see that the this side doesn't exist. So what I can do is I can come down here and draw tools. I can draw members. I can draw a member that goes from there to there. All right. I can escape. I can double click on that member. It'll open up its properties. At the moment, we've got sections 2, 4, and 12. So I'm going to create section type 21. And it's just a construction line. And I'm going to call it slab edge. And okay, as long as I've defined an area which is minute, that is okay. I can use it. So it's 21. And if I now want to get all the members that are the perimeter members, selecting this way, select the members, select perimeter members. Okay, so it's picked up, select I've now got it's automatically picked up all the perimeter members for me. Now I can right click and there's an option to where the and I come back to my, I think it's in the tools, member tools. I have an option here to generate offset members. So generate offset members. Down the bottom, pick a reference point on either side. So I wanted to go outside. And the distance I wanted to go outside is 2 meters. So I've got that. All right. And now I can delete this one because I don't want it. And I can start now going into the tool. So drawing tools, we have this draw plate mesh panel. And of course, the very first thing I'm doing is it's asking me to draw the boundary. So I can pick up the boundary and you'll see it'll pick up all the nodes in between. And I can come along to this one here. and then automatically it'll finish on itself there. So that's finished the first thing. That'll allow me to draw openings, and I can draw a circle, and if I sitting on top of this, I can move my structure around. I need to move this around, so I can go in plan view, and in plan view orthographic as well if I really wanted to be careful. So now I can put a circle. I want a hole in the structure. It's circular. I want it there. I can type the position, and I can type the radius I want as well. So all right, so that's the circle. Then we can draw hard lines, and of course the hard lines can be, if I go back to orthographic, right, hard lines can be any of the lines that we've got internally here. So we can pick up hard lines. Sorry, draw hard lines polyline. All right, so I can go from here to there to there, and then finish the line, and so on. And then I can come and draw hard nodes as well, which where I can control. I can control the meshing density. I can just place them wherever I want them. Maybe these big open spaces, the meshing doesn't need to be so big. I'm not being careful. I'm just randomly going. So we go. And then we go to the next option, and it goes to those features. So I can set the boundary side, say 0.5. The default 0.5 and the boundary 0.5. I can make them smaller where the openings were. We might want to be 0.3. And the hard lines, I've only done one, but 0.3, I want to find a mesh where the hard lines are. And then you've got these controls. You've got controls here and the plate thickness as well. And so we make that 400. And plate offsets, we're not going to use them here. We'd use them for the drop panels. Then I can go, okay, too many elements, fine. I'll make that 10,000. Now it'll romp off and do its stuff. And there is my mesh. If I go back to rendered mode, you can see what it's done. And the hard line was defined only for that wall, so you can see how it's meshed in at that point. It's meshed the member as well. I didn't define for the others. And so it goes. And where the hard nodes were, you can see the spacing here, particularly in there. There's a bigger, and I had a couple down here as well. So where you want it finer, you can play around with those controls. That is one of the other tools as well. And of course, yes, I can copy this above. So if I want to make select the plate members, and I can also use as an option for floors. So generate diaphragms. And there's an option here to also generate multiple floors. Okay. Now we're going to move on to the tanks. There is a folder called tanks. And in that folder, there are a number of options. I've called these seed files because they are certain types of tanks. So this is a flat example. There is also one type that has a dome in the bottom and a dome at the top. And then there's a INSEE tank as well. The reason I've got these here, particularly for these workshops, is the data that has to go in to generate this tank. So this is how it works. It does the same for our portal frame, industrial portal frame. Very similar to the tank here, the steel structures that it generates those industrial portal frame structures, and all of the wind loading and everything as well. The same as what happens with these tanks. There is a wizard that goes with it, and the portal frame wizard is this one here. And then the tank one is hidden amongst the others. We have a footing wizard, so you can generate the footing, and it automatically adds the column positions, and you can do punching shear tests, and you can do your area of steel contours and stuff like that as well, which we'll get out of the tank. So the tank wizard it's automatically picked up the type of tank. And so these three diagrams here dictate the tank types. And there's a lot of work coming up in this area, and we have quite a few new client potentials that are really excited about the work we've done on this tank builder. I can make a change to the wizard now. I can make it 25 if I want to, and then I can come to the substructure, and instead of having 37 columns, I can change it to 21. I think I've done that before, and I find that the columns, because the column thickness was too small, when I get into design, concrete design, the concrete columns were failing, so I had to increase their size. Anyway, the idea is that you use the wizard to make your changes geometrically, and then everything is perfect for you to carry on. There is also, so all the tools are here. A tank geometry, you've got the tank itself, you've got the wall of the tank, you've got the ability to have a balcony, included or not included. For some of the tanks, they've got the spiral staircase. I think in the INSEE tank, you can have that included as well. And then you get the top cover. We have allowed for pinned connectivity, so if anyone wants to precast these structures, you're able to create a pinned connection instead of a typical concrete beam, so a concrete slab to slab connection, which will be fully fixed. So I can just tick those. The substructure, column types, I've chosen circular. You've also got the ability to use the ones that are offset versus centered, like these here. And then you've got the staging levels of the tank too. Then you get to the loading, and self-weight is included. And then there's some loading that's allowed for, both dead and live load. And then you get to the wind loads. Not in this one, but all the others, we have a complete integration with checkwind. And that's, if we have enough time, we have a quick look at that tomorrow. But it's not yet being put onto here. So this is inputs ourselves. And then the settings that we need to use, changes are made here. And then we go to seismic. And this is where the really nice things start. We have a scripting language, so if any of you, being academics, is very smart, you can actually control SpaceGass from another application using the scripting. And you'll see that what we're going to do now is we're going to open up another model, not the one that's already there, this model there. We're going to open up a one separate from it, which is just the form, the frame, and place some dummy members connecting to a point which is in the center of the tank. The tank structure itself will go, so it's just the framing that is used, and we apply a 10 kilonewton load at that point and get the deflection at that point. Okay, so there's, if I click this, it'll go off, and you'll see the new model behind the scenes, this one here. If I move that away, you'll see what it's done. And it's calculated the deflection at that point. Now I can go ahead and generate the tank. Already now I can just do a report on the tank, and we have a detailed report. So gives you all this level of detail. And now if I hit OK, we'll generate the tank. So there's my 25-meter tank. And if I just hold my right button down, primary loads are here. And live load, for example, has two categories of load. So there's the cover slab. So if I turn the loading diagram on, and you'll see, what am I doing? Yeah. So the cover, yeah, you can see them increasing. I can use the contour option as well to show. If we go back to this and we use the plate pushers using contour, and you've got those contours that match to that. Okay, so that, turn the loading diagram off. All of the, it's generated the groups. We have load case groups, the ones with brackets here. So you can create a group, and the groups are what we use to control output and to control the analysis that we do. So the seismic is a seismic equivalent that comes from 1893, and we haven't done a spectral analysis, but if it's depending if the period exceeds 1 second, I think is a requirement, then we have to do spectral as well, which means we have to, yeah, and we're not doing that today, but we'll be doing that most likely tomorrow on the workshop session. Okay, so what do we want to see from here? Let me analyze the structure. You can see how long it takes, analysis. I'm going to do linear static. And it's automatically picked up the load case groups.
David,
Yep,
can we take a little break?
sure.
About 10-15 minutes. We can come back in 10 minutes.
That'll be perfect.
Yeah,
Yeah.
You've also been talking since morning.
I know. Anyway, that analysis has taken 5 seconds. And so I don't know what we're going to do about the... what I might do is get off Google Groups at the end of this session, and see if we can sort out one of the people's computers. If we can get one right, the others will all be the same thing.
Yeah, actually, we've tried now many times. It's the file license file. It's not picking it up. It's saying that there have been too many login attempts. Now you've been logged out.
I have to
So
see
some
this.
reset email is now going. Must have come to you. We were trying in our lab. So some reset emails have gone back to administrator. So I'm understanding that's you. So
Okay.
I think our password file is not working somehow.
Okay, I'll have a look at my email now.
Yeah, sure. Not an issue.
Okay, so we'll be back at what time? 5 to 12?
Yeah, 12 o'clock is good. Yeah,
12 o'clock, that's 15 minutes.
right.
Okay, thanks, Simi.
Yeah, thank you, David. Thank you.
Session I had earlier, so you need to find the SpaceGass utility and use right.
The SpaceGass utility exactly where in the C drive itself.
You can go hunting that
Program
way.
files inside.
The best way is to go down to your main menu, which is the start menu in the operating system.
Yes.
And there will be a
Yeah.
set of program folders, one of different names, Microsoft. One of them will be SpaceGass 14.
Yeah.
And under
Yes, I
that,
got that. I reached
inside-
that folder.
inside that folder will be SpaceGass 14 utility. And you have to right click on it, and there's ...
Mhm.
more options, and you will see the option run as administrator.
Okay. Yeah. And I copy pasted that file, the new file in that folder. That is how it should be done, right?
No,
The PWD file.
PWD files shouldn't go in the program folders, but it should just stay in your temporary folder somewhere on your
Okay.
in your download folder on your desktop,
fine.
wherever, doesn't matter. But that's where the software
Just
installation is.
open and copy paste the login. Yeah,
Yeah.
login password. I just have to copy paste from there. Yeah. Okay, no problem.
You don't have a login and
I'll
password.
do it. You can continue, David.
Yeah,
I'll
the
get
only
that.
login and password you'll have is for your operating system, not for SpaceGass, because you're not administrator, right?
Okay.
You
So,
have to.
but it is popping up. I'm opening the SpaceGas software. At that time, it is asking login password, and that is what is happening. That
No,
is the
you need to
issue.
reset your registration using the
Like,
utility. Run the SpaceGass utility and reset your registration.
Okay, fine. But it did pop up, and I had clicked administrator. But I will do it again. No problem.
Yeah,
David, you
but
can continue. I'll get back to you.
okay.
Sure. Yeah.
You mean my screen is being shared?
Yes, we can see it.
Okay, this is where we got to before the break. And so we've got 45 minutes now, correct?
Yeah. We'll wind up by 1:10 something.
Yeah, so the static analysis for that tank took only 3 seconds. That's linear static. As I was saying earlier, non-linear behavior plates becomes important as well. And so, these are the things that we have to consider in terms of what the user is trying to get. But in terms of meeting what's being done, this tank is now, the analysis is run. And I can start looking at things like deflections and start looking at design criteria as well. So looking at the filters that I've got, I'm just going to get the tank walls, balcony, the base slab isolated by itself. And if I select, there's many load cases, I'm just going to select one of the, this one, tank full 101. And getting back to looking at the deform shape of the slab. Turning off the undeformed shape, so you can see what we've got, turning off the nodes that are not connected. And you'll see that we've now got, and if I hold the D button down, I can exaggerate that. So that's my concrete base slab in the tank. And at this point now, I can start looking, not just deflections, but I can start looking at the analysis results. And I can also not only, I can go and look at reinforcing, and there are contour options. And you'll see that currently it's configured for IS 456 2000. And there's some controls in terms of what you can do for the output. The other design codes, of course, are the Australian design codes. So getting back to that option, if I go back now to my reinforcement, I can show the reinforcement in different levels, both on the deflected shape or not. So got your bottom and your top. If I move over, you'll see what it's showing me. It's showing me the top and bottom steel, minimum requirements for that design. Okay. The other thing I can do if I want to get flashier is I can actually take a, so I'm going to turn the meshing on. Deflected shape I'm going to turn off. Turn the meshing on. I can also take, I can draw a plate strip which goes from, say, there through to there. And turn the nodes off. I can edit that plate strip. Currently it's a uniform plate strip which is 1 meter wide. I can have offsets to the left and offsets to the right. And basically what it's doing, it's interpreting from the analysis all of the plate element details. There are results in the plate elements from the analysis to interpret a bending moment and shear force and axial and so on component. So I can make some changes. I can make a variable width if I want to as well. At the end of the day, I now can say if I turn on the bending moment diagram, so you'll see I've got now plate strip is bending moments can come in. This is what I've got, my M for moment. Right, so I can actually now take this plate strip and I can convert it as to a concrete slab strip. So one is analytical. This is now design. So what it's doing is it's opening up. It's actually going through and looking at, so the columns that are in that inside that tank are showing the location of shear. And of course the shears are used to give you the supports for the slab. And then move into the design interface for the slab strip. And the slab strip is basically just like a beam. And it's highly interactive. You're given a three-dimensional view of the beam, which you can play around with here. You've got the cross sections we're at each zone. Currently, we're located at Wood Zone. This is zone number 9. So these different zones across, you can click any one of them. And the reinforcing is there. We can manually control. We can actually turn auto. There is a lock. You can lock a section once you've got it correct. So you can actually place your steel wherever you want it as well. You can override the automated steel if you want to, but then you can do a design check and it'll come back and cover it. There's a lot of effort to go through this in much more detail. but I haven't actually added the load cases, so it's using the defaults. But if I want to force it to use the ultimate load cases and the serviceability load cases, you can see it's updating each time I make a change. How I can avoid that is to turn the auto off, and then I can come and add the serviceability loads, which will be these, and the sustained load, which is also this one here. So the use of groups, absolutely, my conversation earlier about absolutely fundamental that you work only with combination load cases. So now I can rerun the design. Yep. And then I can OK and say it will automatically save into the collection of designs that it's got, because we can then output that as well. All right. And now if I'll turn the plate strip off. So plate strips can go off. Go back to the no filter, the tank. Turn on the meshing, plate edges and the beams as well. You get a better feel for it. There's no dome on this structure. There is an option to show gaps at nodes, which is on the left here. And what it does is separates the, so I can actually see the nodes, and I can go inside, and you can see the submerged columns, which are in here. And you can see the beams which are supporting the slab underneath. And this, once again, gets back to the conversation about the accuracy of the physical. So you'll see that these support beams and the ring beam, slab sits on top of the ring beam, and these support beams, the tops of them match the top of the slab. And if I want to do something really exotic, working with a 3D structure like this, I'll change the subject again. Hang on. Let's pick up a column. So I'll just take an individual column. So there is the conversation I had earlier when I wanted to change the staging. This passed, I couldn't get the column to pass the design because it was too small, because there were 26 columns instead of 31 columns. So there is a, rerunning the analysis, playing with different configurations, and then coming to get your design here. Of course, this is all to IS456, and we've got, the ability to, it includes 13920. Being a column, it won't include the allowance for crack control because cracks are not considered for the columns. But I can include 13920, and it will then go into redesign mode and update mode, so on. So I go out of here. If I just want to be outlandish, I can just take the ring beam. So I'll go in many ways. I can select it. You can see it's now backed. I've taken that option for show gaps at nodes. I've turned that off. What I want to do is quickest way I can get it is the ring beam itself has been generated. So the ring beam should appear here. Where is the base ring beam? Is it here? Yeah. I can do it. Oops. I can do a Control A. Select all of the members. Now I can right click, look at the analysis results chart, and I can select the moments have been turned on. Displacements can come on as well. So there are my displacements, there are my moments. This is just for one load. I can do that for all of the ultimate load cases. So they all appear there in different colors. And of course I can envelope them as well. So I can create an envelope, which may be useful. And that's giving the envelope of, my envelope probably includes minimums and maximums. So I'll just go for the maximums and we'll have fewer lines there. Of course, this can be output to hard copy and soft copy as well. But yeah, if I go back to that control A, select all the members, right click, I should have the ability to edit a concrete beam. You'll see now that I've defined the loadings, so it's brought them across automatically. I've still got my auto button on, so each time I make a change it'll update, but it's got a fair amount of calculation to do on that ring beam. It won't take much longer, and it should then come up with some kind of initial design. Here we are, and I'll just turn the auto on because now I can see I've got the crack control, so I can turn the crack control on, and my choices are IS456 or 3370. Being water retaining structure, I'll select 3370, and then I can click on the auto button and do a design or check. The design it's selecting the reinforcing, and it's making its choices of spacing and of cover based on the parameters that have been configured. There's a number of default settings and for each one of the major components. So for the slab and for the plate strip and for the column and for the beams. You can go and there's a number of settings that can be defined for each one of them. Of course, the output, there's some abbreviated output here. The area of steel is included in that. So things like area of steel, a lot of work we're busy doing on some of the output. So I think you'll find AST is there. Just toggling down through it. Conscious of time as well. Yep, there it is. Okay, any questions? All right. Seeing we've only got half an hour before lunch, I want to just show one thing further, which I think is important. Going to my data folder again, just to save time. If I, the portal builder, and portal builder example, just see which one of these I want. Yeah. Now there's a wizard that goes with this. And here's your diagram. Here's the inputs, the geometry, various types of roof configurations, and the spacing, the overhangs, and of course, decisions to be made whether you're including or not including knees, and yeah, your eave height. So all the geometry basically of the structure is defined here. And then you get to the sections, which include the rafters. The purlins and girts are kept separate. And of course you have their information. And there is some additional data, which includes the sheeting. The sheeting is very important for wind loading. And then we get to the loads itself. Dead and impose, you'll see wind loads are here. But this is the new feature here, which I've turned off at the moment. And if we have time, I'll cover that briefly tomorrow. So if I turn this on, I go into an interface which takes the structure we've got into the terrain data right at that position. You can go right up to Monday. It's quite incredible when you start playing around with that. You can actually see the level of detail for terrestrial data that we have across India. Anyway, this has been defined for Delhi, so if I was in there, we'd locate the position exactly in Delhi, and it would help to generate the winds. So there are the load cases. These are predefined, the primary load cases, and then it generates all of the complex combination load cases for you. So, pressure at the end, pressure upwards internally on the roof, in combination with dead load and live load and so on. So all of that is taken care of. I'll just close that. And then finally, the steel design inputs It provides and that's what we're going to do after this afternoon session, is to go through creating a small structure and designing it, but optimizing it. So the steel groups, bay 1 and 2 and bay 6, and then the last 2 bays are defined, and you can see the design data. It looks like this. And then also their connection types, which have been automatically based. We have connection design in SpaceGass, which is not finite element methods. It is from the book of rules on connection types through laboratory tests and studies and so on amongst the various universities in Australia. And it's very close to some of the books from the AISC. Anyway, we'll go through that this afternoon briefly as well. Right, then you can generate the frame, just like we did for the tank today. Okay, I'll just cancel that. I think this job has got some, no, it doesn't. I have to open the other one. So if I go to the Hemel one, so this job was started. You can actually start in the portal, and you can make geometrical changes of your own. So you just leave everything as it was. You don't go and regenerate, because that's what the portal will do. And then you can do some fancy things like adding moving loads. So if I view the moving loads, not too fast to start with, you'll see that there are a number of gantries. There's one here. It's moving backwards and forth, and there's one here, and then there's another one up this side, generating loads. So pretty useful. The portal frame wizard together with the moving loads is quite useful if you do a lot of work in those kinds of structures. All right, drawing. What we're going to do this afternoon, if I had all of you with your own computers, it would have been much easier. I am still hoping that we can actually miraculously get you working today. Himi, you did tell me that one person has got a computer working since the reset. Hello?
Hello, David. Yes, we are trying. I think Komal, ma'am, one of the other participant was able to do it.
Okay.
Is Komal, ma'am? Here?
If it's worked
Yeah,
for her,
one person has been.
I want
Yeah,
to hear
it has worked for her.
Yeah, so the others are still trying, or they're going to try during the lunch break.
Yeah.
Are we able
yeah.
to start earlier tomorrow or something? We haven't got any more time today, so we'll finish up. I'll start what we're doing on the basis that I hope that everyone manages to get their software working by tonight. Okay? Are you with me? Himi?
Yes, sir. Yes, sir. Himni, ma'am. Yeah.
That's Monisha. Yeah, I'm just checking with you tomorrow. Our next session is tomorrow afternoon, correct?
Yes, yes. No, tomorrow morning, David. Tomorrow morning, 10 o'clock.
Tomorrow morning at 10 o'clock.
Yeah.
Okay. So, and our session today finishes at 1 o'clock, which is in about 20 minutes time. Okay.
Right.
So what I'm saying is that please keep me informed as to who managed to get the software working. If there's more than one, then everything should be fine. It may just be that they're not doing the right thing, which is to run the utility.
Right.
As
So, Professor Thomas, you've been able to do it? Megha, ma'am, you've been able to do it?
Actually, ma'am, there is some issue with my system. I think it should work. There is some issue with my system. It is not finding that file when I'm searching for it. It's somewhere here. I don't know. There is some system issue. So it should work.
I
If
think
you
it
give me
will work
15-20
because-
minutes, I could do it.
Right. I
Yeah,
think
it
one
will work.
participant
It
has
will
been
work.
able to do, Professor Khushbu. So I think we are good to go. We'll try on our
Yeah,
systems also.
Yes, ma'am.
I
I have
think if Khushi can come along, if Khushi can come online, it would be great. I think Sir wants some, if it is working or she can come in for some time, then I will join in. Is that fine?
I'm
Himi
sorry,
ma'am,
I didn't understand.
if
I didn't.
she can be online.
Who?
Khushbu ma'am, you are saying?
Khushbu ma'am, the one who has no uploaded it now, is able to download it
Yeah,
and
yeah,
install
she's
it.
online. She's
She
unmuted right now. She's talking to you, right? Right.
Yes, ma'am.
Yeah, the file that you're looking for is TitanCloud.pwd, and that is gets saved wherever you put it, because it's in the email I sent you. So you save it where you want to, put it on your desktop. So it doesn't have to be any particular place. So you should. I don't understand why you're having problems finding the PWD file, because you've copied it to where it needs to, wherever it doesn't need to go anywhere. It just needs to be there for one-time reading, and then you can delete it.
Excuse me, sorry to interrupt.
Yep.
When we download it again, it get a number. Let's say I have downloaded a file. The number when I download it again, it gets a number 1. So kindly delete the previous file and then download it. You'll get the number and you'll get the same copy in your downloaded files.
That's correct. You can just delete. You can change it anyway. The other one, delete it. Yeah, delete it.
If you have a numeral in that number, then it will not pick that file. So kindly delete that numeral of 1, 2. You will number of times when you're going to download the files, you'll get the numbers 1, 2, 3, 4, 5.
Yeah.
Please delete
Yeah,
that one of the number. You'll get the file.
That's what on your operating system, because if you have more than one, it changes it to like that. Yeah. So you have to do it on your machine. Just make sure that the brackets and number don't appear. I'm pretty sure if I go back to my folder, which is downloads folder, TitanCloud.pwd is the file I sent you. So if you had more than one, then of course that will happen. So you just delete the others and download it again. We'll change the name back to what it should be. Do you understand? All right, I'm going to carry on. We okay with that, Himi?
Yes, yes, David. We'll carry on. Right.
Yeah. Otherwise, we'll. This is really irritating. I don't know what to say or what to do. Anyway.
Yeah, I think it's happened for the first time. I don't know why this time. Anyways, we'll keep on going.
Yeah. I'm going to turn on some grid lines, and I'm going to auto-generate. There are 5 meter intervals, and I want 5. And the number of grid lines I'm after is 3. So it'll automatically put in. I'll just use the auto-generate here. Same story again, 3. So that was the option down the bottom here, on the left, down the bottom on the left-hand menu. There's the grid generation option. So basically 5 meter by 5 meter by 5 meter. I can also have vertical ones if I chose to do that. And you'll now see that my grid is there. We're going to create, this is part of the, we'll finish, we'll try and get some of the geometry done now. And then hopefully you can give it a go before we start tomorrow. You've got tonight as well. So if I right click in drawing tools, I can draw members, and you'll see it can snap to the grid. I can also, the starting point, I can also type the coordinates. If I type 0, it automatically knows where 0 is. I want to then, you'll see it's moving in the direction of the axes. We have the global axes, and you can see their color. So from this position, I can, it will automatically looking for a vector value now, because it knows it's aligned with the z-axis, with the x-axis, and with the y-axis. And so I just want that to be 5 meters. So I just hit 5, and it's a vector length. And I'll just hit the escape button on the mouse to get out. All right, so just rotating and went back to where it was. You can control how you position by clicking on the cubes button, and if you right click on the cube, You've also got some additional options like the orthographic view that I used earlier. So if you don't know the difference between orthographic and perspective, perspective is how we look at something. In 3D, we look around bends, but orthographic is like the plan view on the drawing board. It's basically physically only flat, and there's no round corners. So particularly if you're wanting to make some changes to a part of the model, and orthographic is quite useful. One thing to remember is that if you leave orthographic turned on and you have a large model, you'll find things going slowly. Your graphics is trying to rotate an orthographic view. So remember to always go back and turn right-click and come back to perspective view, just by the side. I'm going to double-click on this member to show you the properties that come up. So it's member number 1. It is normal type. You'll have compression only, tension only, and cable that you can choose from. The node fixity for each end of each member, node A and node B, by default is fully fixed. And the direction angle, or you can choose a node to point at, various ways of doing that. So these are your options, node, axis, and so on. Then the section from the library. So we have 2 options. We can go into a shape builder, which is really useful, or we can get sections. For this particular structure, it's a steel structure. It's going automatically. It knows I'm in India. And I think it'll know you're in India, so it should by default take you to the Indian design code. I'm a young engineer. I've just joined the organization, and I've been given the criteria of this workshop. Number 1 is we're trying to minimize the amount of steel that we're going to use to achieve the utility we're after. All right, so that'll get defined. And secondly, deflection, maximum 20 millimeters at any position across the structure. Total deflection, no more than 20 millimeters. Number 3, there is a egg crate flooring on the first floor, and there is a roof structure on the top floor that connects to the steel girders, not to the columns. So it's completely connected to the beams on the second floor, right? And of course, the other criteria is that it meets the, satisfies the design of IS 800. We don't have time in these workshops for the seismic checks as well, because there are seismic checks which are separate. They have very specific load cases, and the design checks are slightly different. And they include things like web to flange ratios. So the sections that we use become quite important. So I'm new at work, and I've decided to start off with a standard column, and I've chosen the very weakest section I can, because once again my focus at the moment is I'm trying to save in the weight of material. So this is a good workshop you can do with your students. Once you've got SpaceGass working properly, you can run these kind of workshops for them as well, and lots of ways you can do it. The material by default we need to select first time is steel, and that's pretty well okay. Now I can copy this column if I want to. I can go copy, and I can copy 2 locations, and it will allow me to use the next available. If you're worried about your things, and for me, I'm not worried about the numbering. I'm just going to go to this corner and to that corner. What am I doing? And I'm going to undo that. All right. And I'm going to copy 2 locations. And it's asking me to pick a reference point. So that's where I went wrong. Pick up the reference point, and then you can go wherever you want to. I'm going to get the corners done that way. Now I'm going to draw another column, or I can just take this column and I can copy to a location, once again, picking up the reference point, endpoint, and endpoint. What I want to I want these to stay as section number 1, and all the ones on the corner, but I want this one and this one to be changed to section number. There's only one, so I'm just showing you. I want that to be section number 2, and I'll come back to my library, stand with the standard columns as well, select the same number, same defaults, and then I basically got section number 2. So if I turn my section and materials on, you'll see that I've got if I click on the first section 1, and I click on section 2. Okay, so now I want to do the same as well. So I'm just going around this because I'm talking. I would have done it quicker. So I want to copy 2 locations. The reference point is there. And I want this one, and I want this one. So you'll see that it's used the last section. Now, there is a setting. This is when it's useful that you've got your own systems running under the settings. Please remember this. Under the general preferences, the very, very first option you'll find is unticked. So use previous attributes. It's really useful because you can just, select, I can select that member and then hit the escape button, or right click on the mouse is the same as escape. And then I can go and I can copy the properties of that to another member, or I can draw another member and it'll use section 1 as the properties for that particular element that I'm working on. So I've got the columns in place. Now what I want to do is we want to do the beams, right? So how are we going to do that? There's beams in 2 directions. So start, drawing tools, draw members, and I can just physically draw across. You'll hear the pop sound it makes. If you want to wait for it, it snaps onto the end. You can see the value of 5 meters. Everything is there, is right, is correct. Now it's used the section properties for the last column I touched, as you can see here, this one and this one. If you're not sure about it, property 1 is highlighting, and it's highlighting those beams. These beams, likewise as well. I've only got sections 1 and 2. I'm doing extra steps because I'm showing you versus doing it myself, and I would be going through this a lot quicker. So I want section number 3, and I want this to be a universal beam. So standard medium flange beam. And once again, I'm also choosing the lightest section, and that'll be okay. Right. So now what I'm doing, if I look at that, this should be section 3, and of course my material should now show section 3, and they should be highlighted. I can copy all of these. I can copy this one and this one. Copy 2 locations. It's asking me for a reference point. I can select a reference point down here. So I can go across to that one. So I'm just showing you can do it reference to one below it, or you can do it the correct way, which is the one where it's going to. Much easier. All right, and now I want to go the other way. And of course, I may decide to use a different section property for that. But let's go ahead and draw the members. Drawing tools, drawing members. And this one to that one to that one. You'll see now that it's used section 3. And I want the properties to be, I've got 1, 2, 3. So I want member to be on the 4. And once again, library, medium flange beams, 100. Everything else is okay. And then I want to take this one and that one. And first of all, I'll make sure that for you can see we've got 4 section properties. So it's highlighted those members. So I can now go copy 2 locations. It's asked me to pick up a reference point. And there. And there. All right. Now what I need to do is I want to support the structure. So I'm going to pick up all of the nodes, select the nodes, go to the properties, and decide on whether we're going to do this or do that, fully fixed or pinned. All right, so I'm going to go for pin support. because that is conservative. And this is important to have that conversation. So you'll see I should be able to now turn on the left-hand side, I've turned on the node restraints, and the diagram showing. Now, if I want to check the connectivity, I can just come here and find substructures, and I should only have, I've got 3 substructures. Oh dear, how did that happen? All right, and there's the one. And there is the next one. 2, 3. And so basically what we've got is stuff which is not connected. And it's, there's a reason for that. It's because I hadn't turned my snap on, and there's a quick way of checking as you go along. So I would need to correct the structure because it's going to be time consuming. I've done this purposely because in the workshop, this is what a few of you will do. And as I'm going through, I'm not checking the connectivity. So I will spend some time on this after when we first start tomorrow, and how we correct this and how we avoid it happening as well. Himi, it's 6 minutes to, and there's nothing else I want to start right now. We're basically going to take this structure and we're going to add a second floor to it. We're then going to look at the criteria I mentioned. And then we're going to go through, we're going to read so I'll just do again now. We're going to file here. We're going to import from Excel. I'm going to import from Access. It's the same thing for me. Go back to the folders that we've got and get to the SpaceGass data, jobs, import options. And we've got Excel. Import options, MDB, there it is. I've got a spreadsheet and an access file which will read the loading that we want. And once that's finished, I should now be able to go to the datasheet and look at the load case titles. And it's brought everything in for us. This is really a neat feature because you want to standardize on your loading criteria. You have different countries with different codes, and you have difference between concrete and steel, and you have design codes which influence everything as well. So being able to have someone controlling a particular set of load criteria through an Excel spreadsheet, which can be protected and shared as well, is a pretty neat one. So these load case titles. It's also added the load case groups, which is the important for my design work, and the load categories that we may want to use as well. All right, and self-weight has already been defined automatically. All right, so it'd be appreciated if you would get back in touch with me this afternoon. If you've been able to get things working, my mobile number is on the email. I don't think we can use this Google session because it'll be used in the afternoon as well. Is that correct, Himi?
Yes. We have some other session planned for this platform.
Fine.
For 2:30.
Okay. So my mobile is there, but it's probably best that I'm on my laptop at the time. But I just need to know that you're able to access that file and register. If one of you has worked, it should all of you should be working. That's basically how it works.
Right. I think even Professor Manigol, I think he's been able to do it as well.
Okay. My apologies for this. I can't control, but as I said, it seems to happen. We need to do something in our management of it because maybe I need to give you the information about 2 weeks earlier. But what happens every time so far is everyone tries to load the software the night before, the day before. And it's very difficult being able to manage that when that happens. So if it had been 2 weeks ago, then we could have made sure everyone was working. Okay?
Right.
Lessons learned. We have to improve. Thank you very much, everyone.